All right, so good morning, good evening, good afternoon, and welcome. So today's lesson is the beginning of chapter 9. Okay, so what we're going to be doing now is we're going to move into talking about graphing quadratic functions. Okay, we've dealt with linear functions, exponential functions, and I gave a demonstration in class about those. Now we're going to be dealing with quadratics. If you do not have these lessons, please make sure you guys go into Canvas and download the notes. All right, so we've been talking about linear and exponential. Remember exponential? Linear is just a straight line. Exponential is the ones that look like this, okay? Or it would look like this when you graph it. All right, it would be straight lines. Now we're going to analyze characteristics of these and graph the functions. If you have the notes, please make sure you highlight and annotate. Also, if you want to keep if you have your books at home and you want to follow along, we are on page 559. Okay, so we're getting near the end of the book. It's been a long year, a great year actually in our classes, but we're on 559. Function, standard form, it's a big one. Parabola is just the shape of the graph. Axis is symmetry, we'll talk about that. And vertex, maximum, minimum, these technically are the same thing. Okay, we're going to talk about a vertex, but a vertex can actually be also called a minimum or a maximum. All right, so parent functions. Big key thing for today's lesson, guys, is to make sure you know the A value, the B, and the C. Okay, that's the big key aspect. We'll talk a little bit about this formula here, but because we're going to be using Desmos heavily in this lesson, I'm not going to go too much into this formula because we had talked about in class, I want to teach you guys like it's 2019, okay? Not like it's 1958. We have the technology, I need you to use it, and I need you to understand what we're doing and going faster. The only other thing is the Y-Intercept I'm going to ask you a lot for is actually the same thing as the value C at the end. So just remember that. Okay, so use the table of values to graph this. I don't really want you to use the tables of value to graph this. I just want you to graph it. So if you guys were to go into Desmos here, okay, your setup would be x squared, and it's going to be minus x, and then minus 2. Okay, when you set these up, please make sure, what are you looking for? Okay, according to the notes, you're going to state the domain and range. I also want you to add to your notes one other aspect when we see equations like this. Okay, we are always going to be looking for the domain and range today. On every single thing we're doing, we're going domain and range heavy because I need to make sure you guys get that down. I also want you to find what the A, the B, and the C equals for this equation. Okay, so remember what A standard form is. AX squared plus BX plus C. Okay, so what is the A value for this equation? Well, it's 1 because there's a little 1 right here. What is the B value? It's actually -1. Okay, and then what is C? That's set off by itself, -2. Now you need to state the domain. Well, remember domain. Domain is going to be all x values, okay? Now, let me rephrase that. The domain on a graph is everything going left to right, okay? Now, on the video, that might go backwards, but the domain is everything going left to right. So does the graph stop going to the left? Does it stop going to the right, okay? And then it has to ask you, and it's in correlation to the x values. Okay, so can you put in any x value, get an answer? And then the other piece is range. Range is vertical, okay? Is vertical. Or the y values, okay? So what is your range? Okay, so for example here, okay, if you look at this graph, you're going to know the first one here, what is my domain? It's going to go left to right. If I zoom out on this, okay, you guys know that if I zoom out, you're going to have a hard time seeing the graph. But one thing in relation to your homework as well is up here there's a little settings. It's a gear, I like to call it, but it's a settings button really. When you click on this, what happens is it allows you the opportunity to create a table. Okay, I want you guys in your homework to be able to do that, to work on the homework. But what this does is this actually provides me points. So I know at 2, 0, if I go 2 over, I get 0 for the point. If I put in 4 or 10, if I put in 10, 10 over is 88 up. So does it go high? Yes, it does. Now, if you guys watch this, if I start putting in zeros, 100, 1,000, 10, 100,000, 1 million, am I still going up? Yes, I am. So I could keep going on here, okay? And ladies and gentlemen, the value is going to still go. So it's technically, it is to infinity. It's just you can't see it on the graph because that number is 1 with 50 zeros after it. I don't know what number that is, but it's gigantic. So no, domain is going to be all real numbers. Okay, now what is the range? Range is the vertical or the y values. So if you're looking at this graph, where does the range stop? Well, it stops right here at this point. So the graph goes up, it comes down to here, stops and goes back up. So what is the range? The range is going to be every value that is greater than negative 2 point. So it's going to be y is greater than or equal to negative 2.25. Right? That is my range. Okay, because it's every value of y, when you're looking at it vertically speaking, okay, coming up and down, it's going to come all the way down on y to here, and it's not going to go any farther. So if I trace this graph, it's every number greater than this, but then as it comes down, this, ladies and gentlemen, is also called the vertex. Okay? Vertex is the point where it stops, the graph stops and turns. And then this is also a minimum value. So when we talk about what is the minimum, this would be a minimum. If the graph turned, and I can make the graph turn, if the graph would turn like this, then, ladies and gentlemen, what does it become? This vertex here now would become a maximum, okay? This would be now a maximum point because it's the maximum height, and then it would come back down, right? So just know those are the different terminologies as we move forward. Okay, your guys' turn on the notes. All right, what I want to make sure you guys understand is to graph it. Give me the A, the B, the C, so A, B, C. And then what is, so A, B, C, and then what is your domain and range? Okay, so if you graph this, you know your A value is 1 because it's in front, your B value is 0 because there is no X value, C is 3. Domain is all real numbers. Okay, once again, you may ask yourself, Mr. Steiger, is it always all real numbers? As long, technically, yes, until we get to transformations and we turn these graphs. So right now, if the graph looks like this or like this, is it all real numbers? For domain, yes. We will get to a point, ladies and gentlemen, where we would take this graph and we will turn it sideways. If we turn it sideways, then it would not be all real numbers for the domain, but it would be all real numbers for the range. Okay, so just remember that. That's going to be for future reference down the road. Range, if you were to graph this, you know it's going to be positive, so it's going to come down. I know it's coming down, and it's going to come back up, and it's going to cross at, because the Y-intercept is represents C, and since C is 3, I know it's going to be every value greater than 3. Okay, I know that by looking at it. If you don't, graph it, and you'll realize that it's all numbers north of 3. Okay, now what you're going to do is, like we said here, you are going to be presented with this. I want you guys to be able to read a graph, interpret what you see, and move on. Okay, that is the main function in Algebra 1. All right, find the vertex. Vertex is right here. Okay, so on this, we're going to go vert, we're going to go axis of symmetry. I'm not going to write it all the way out. Okay, and then we're going to go Y-intercept. I also want you to do domain, and I want you to do range, just so you guys continue to do it. We've suffered, when we took our test, we sucked at domain and range. I want to make sure we get better at identifying what a domain, what a range is. Okay, vertical, or a vertex, is going to be this point right here. All right, we talked about it's going to be 2, -2. All right, axis of symmetry. What is an axis of symmetry? If you guys remember, we're approaching Valentine's Day season. When you guys were younger, you had to make a heart. Okay, if you wanted to make a paper heart, what would you do? You take the piece of paper, fold it in half. Then you would cut a little heart, a half heart out. And then, ladies and gentlemen, after you're done, you fold it back open, and you have perfect symmetry. That's what you're working with here. So what line would create perfect symmetry? It would be the line down the middle, which is on 2, So your axis of symmetry is x equals 2. It's not 2, it's x equals 2. So you know it's the entire line on there, okay? What is the y-intercept? In this graph, it's where it intersects, the graph intersects the y-intercept. It is 2. Domain is all real numbers. And the range is going to be y is greater than or equal to negative 2, right? Because it stops right here and the graph goes that way. Okay, so if I know it's at negative 2, that's great. The other one here, axis of symmetry. So I'm going to go vert. I'm going to go AS for axis of symmetry. Y, INT. Okay, if you want to write them all out, you can, but I don't want this video to be 30 minutes of me just writing down the same thing over and over. I mean, in terms of writing out the words, because we're going to be doing a lot of it repetitively. We do it now during the notes, or we do it in the homework. Axis symmetry would be 2, 4. All right, I mean, the vertex is 2, 4. Axis of symmetry would be what line would split this graph in half perfectly. It would be x equals 2. Okay, what is the y-intercept? On this one, ladies and gentlemen, the y-intercept would be right here at negative 4. Okay, and then what is the domain? All real numbers. And the range is going to be y is less than or equal to 4 because it's coming up here and it's going down. Okay, so your highest point, also a maximum, would be 4, and it's going to be at y is going to be less than 4. Okay. Make sure you guys understand that. All right, next, couple other things. You guys do the same thing. Remember, I want you to give me, not only do you give me the vertex, okay, but give me the domain and the range. All right, as you move on, vertex. It's going to be 1, 4. Okay, axis of symmetry would be x equals 1. Okay, and then, excuse me, my y-intercept would be 3. And then my domain is all real numbers. And my range is going to be 1, 2, 3, 4. So it's going to be y is less than or equal to 4. Here on this one here, it's going to be the same setup, okay? Axis of symmetry, your vertex is going to be 1 over 3. My y-intercept is going to be 4. And then my axis of symmetry here is going to be x equals 1. Okay, that would be yes, axis of symmetry, sorry. Y-intercept, I've been saying it all day, so I'm starting to get a little crazy with it. Domain is all real numbers. Okay, and then my range is going to be every y value that is greater than or equal to 1, 2, 3. All right, that's the big key aspect as we go forward. Okay, now what I want to make sure you guys can do is understand, we're going back to the equations, okay? You're going to graph these in Desmos, but before you do, I want to make sure you guys understand a couple aspects here. What is you're going to find these 3 things, but I want you to find the 2 other things that go with it. What is the A, the B, the C, the domain, and what is the range? Okay, it's a big key factor for you. What are these values? Okay, once you do that, then I want you to find the vertex, I want you to find the axis of symmetry, and then you would find the y-intercept. Okay, I'm using shorthand so I can kind of move through it quickly. Like I said, saves a couple seconds. A value would be 2, B would be 4, C is negative 3. Domain, all real. And then the other ones, I have to actually, I do know from this, my y-intercept is going to be negative 3. Okay, now there is a formula, because I don't have time, well, there is a formula you can use that if you don't want to graph it, you technically can solve, okay? Which it would be x equals negative b over 2a. Okay, I showed that in all the classes today. So I want to make sure you guys can do this. So if I know the a value is 2 and the b value is 4, I could substitute over here because I don't want to go graph it. It would be negative 4 over 2 times 2, right? Because if I plug these numbers in, to here. Now you may ask yourself, where is this formula? It's actually on the first page of your notes on that little table. It says, how do you find the axis of symmetry if you do not have a graphing calculator? This is how you do it. 2 times 2 is 4. So x, So in this case, x is going to equal -1. Okay? So 4 over 4 would be 1. If it's a negative, it's -1. And then you'd ask yourself, okay, so that's my 1 point. What is my vertex? So your vertex would be found by plugging it into this original equation. So my y value is going to be y equals 2 times -1 squared, right? And then it's plus 4 times -1, and then it's minus 3. Simplify that, be y equals 2 minus 4 minus 3, y equals -5. Okay, that's just simple math, solving that. So I know my vertex on this equation is going to be -1, -5. Okay, that's my vertex. What is my axis of symmetry? Your axis of symmetry is always actually going to be whatever your x value is. So it's x is -1. Okay, and then what is my range? My range is going to be whatever this value is. So it's going to be y and -5. And then is it positive or negative? I know it's positive, so it's going to be every value greater than or equal to -5. Now, if you graph this and you got those, great. If I spoke too fast, rewind the video and do it again if you need to. Here, same thing. What is A? What is B? What is C? Change color. And then what is domain? What is range? Okay? And then I want you to know what is the vertex, axis of symmetry, and Y-intercept. Okay? So if you don't know what those shorthands are, sorry, but that's kind of what we did. -1, 6, 4. What is the domain? All real numbers. Okay? What is my range going to be? Well, I don't know what the vertex is. I don't want to take the time to do this math. So it's going to be -x squared. So my graph here is going to be -x squared plus 6x. And then what was the last piece? It was plus 4. Oops. Plus 4. All right, so I know my vertex is going to be on this. If I click on it, it's 313. So knowing that my vert is 313, I can figure out the rest from there. Axis of symmetry is x equals 3. Okay, my y-intercept is the c value of 4. My range is going to be 13. This is negative, so it's going to be y as my greatest value. 13 is going to be the thing. So what you want to do, did I write that right? Nope, I wrote that wrong. Hold on. Real quick, I was thinking, like, I don't think I wrote that right. So it's going to be y 13. So every value is y is less than 13. Right? So there's your answer to this. Ladies and gentlemen, do this one real quick. Graph it if you must. But remember, I want you to give me, not only do I want the axis of symmetry or vertex, I want the A, the B, the C, the domain, and the range. Okay? And then we'll go through these real quick. I'll graph them. You guys will graph them, and then we'll go from there. Okay? This is A, B, C, domain, range, as well as the vertex, the axis, and the y-intercept. Okay, I want these 8 things every time you guys do this. Okay. All right. Good luck. Write them out real quick. Go into Desmos if you have to. All right, on this one, guys, -3, 6, -5. All real numbers. Range is going to be, I don't know yet. Y-intercept, I know that at -5, okay? I'll come back to the rest of this. This is 2, 2, and 2. Domain is going to be all real numbers. My y-intercept is going to be 2. All right, so let's graph this first one. Negative 3x squared plus 6x. So it's going to be negative 3x squared plus 6x. And then it's going to be minus 5. Okay? Minus 5. All right, graph it up as we go forward. The home button. So my vertex on this is going to be 1, negative 2. So I know which way it's pointed down. So if my vertex is 1, negative 2, I know my axis of symmetry is x equals 1, because remember it always relates to this. And now my range is y and negative 2, but it's going to be negative, so that's the greatest value. Okay. So there's your range on that one. So 2x squared, 2x and 2. So if I go in here, close. If I go 2x squared plus 2x plus 2. All right, set this up. I know my vertex is negative 0.05 and negative 0.05 and 1.5. So there's my vertex. And that's a minimum, right? Because if you guys go down and you stop, that's your minimum point. Axis is going to be x equals negative 0.05. Okay, sorry, that looks like a plus. A little weird thing. Range is going to be y is greater than or equal to 1.5. Because every value is above 1.5. Okay, so now we're going to get into kind of how do you know which way the graph opens. It's kind of a lot of the same stuff we've been working on, but I just want to make sure that we're moving on and you guys can understand that if you see a negative in front of it, it technically means that the graph opens down, okay? All right, when it opens, when A is positive, there's going to be a minimum. Like we said, minimum value. If A is negative, it's going to hit a maximum point. Okay, so whenever, technically speaking, you're throwing a ball in the air, the curve it makes is always going to be negative, and you're always going to have a maximum, right? Okay, so consider this functionality, negative x squared minus 2x minus 2. Determine whether a function has a maximum or minimum value. Well, if it's negative, okay, I know it's going to be going like this. All right, negative values. So it's going to have a maximum. Okay, now it's going to ask, state the maximum or minimum value of the function. Well, the value would be the vertex. So what you need to do is go in here. It's going to be negative x squared minus 2x, and then it's what? Minus 2, okay? So, minus 2. All right, you set this up, ladies and gentlemen. Here you go. My vertex is going to be negative 1, negative 1. How convenient is that? So, to state the minimum or maximum value, it's negative 1, negative 1. That's my point. State the domain and range of the function. Domain is all real numbers, okay? My range, if you guys look at it, okay, where does it go up on the graph? It's going to be the height is negative 1, so y is going to be every value less than negative 1. All right, ladies and gentlemen, flip your paper over and do that one, please. All right, 2x squared minus 4x minus 1. So 2x squared minus 4x minus 1. 2x squared minus 4x minus 1. Make sure I did that right. Okay. So when you're going through it, you graph it, you look at this, you interpret the graph. There is, ladies and gentlemen, a minimum, right? So on the other one, ooh, did I say that right on this one then? I think I may have screwed this up. Nope, I said maximum. Good. All right, on this one, there is a minimum value, okay, because of how it comes down. And when it comes down and stops, that's minimum. And then what is the value? It is 1, negative 3. Okay, and then state the domain and range of the function. Domain is all real numbers, so I'm just going to do this. Okay, and the range is going to be y is greater than or equal to -3, because since it has a minimum, that means everything is going to be greater than or equal to above it. Okay. All right. Next, when you guys are graphing quadratic functions, find the equation of the axis of symmetry. This is what this is talking about. As if using the formula, if you don't have a graphing calculator, and using this formula, -b/2a. Okay, you guys can find that. If you know the value and you don't have a calculator or you don't have a computer with you, you can technically calculate the axis of symmetry. Find the vertex. Determine if it's a minimum or maximum by the shape. And then find the y-intercept. Remember, the y-intercept equals c. And then use symmetry to find additional points. Graph if necessary. Connect it. Do a smooth dot. On your homework, you're going to have to create a table. And remember, at the beginning of this lesson, I showed you how to create that table, so please do that. All right, here are the steps. Now what I want you guys to do is graph it, okay? So find the equation of the axis of symmetry. So what is the axis of symmetry on this? It would be -2x squared plus 5x minus 2. Do I want you to use this formula? If you would like to, ladies and gentlemen, you can. Just know A equals -1, B is 5, and C is -2. If you want to do it, you can. -x squared plus 5x. So it's going to be -x squared plus 5x. And then the last piece of the puzzle is -2. Okay? -2. So there's your setup. Okay, my vertex is 2.5 and 4.25. So let me make sure I write that down. 2.5 and 4.25. Okay? So, and then ladies and gentlemen, that is of course a maximum. Okay? Alright, it's maximum because that's the highest point it actually goes. Axis of symmetry is going to be the x value, so it's actually x equals 2.5. Okay? And find the y-intercept. Well, the y-intercept is this value here, so it's -2. Step 4, the axis of symmetry divides the parabola in two parts. If there's a point on one side, you have to do that, connect the points, do a smooth curve. It's already done for you. If I made you draw it, I would want you to draw it out, but I don't. Ladies and gentlemen, try this one real quick. All right, so when you guys do this, 3x squared minus 6x. So it's going to be 3x squared minus 6x. And then, of course, it's going to be plus 2. All right, when you set this up, ladies and gentlemen, here's your vertex. It's going to be 1, -1, okay? So I know it's going to be a little spaz on that one. It's going to be 1, -1 is my vertex, okay? That, ladies and gentlemen, and I know was a what? Minimum, okay? It was a minimum point. Find the equation of the axis of symmetry. It's the x value. X equals 1. Okay, find the y-intercept. It's this value here of 2. Divide it in half, put points on both sides, graph it. I'm not going to do that. You guys know how to do that. Last but certainly not least, okay, we do have a word problem I want to throw in. Talking about cheerleaders at Lake High School launching t-shirts into the crowd every time the Lakers. Here is the equation, okay, where h of x represents the height in feet. The t-shirt is launched after the seconds. So when we do our quadratic, our Angry Birds project that I do plan on doing unless something changes, when you launch those, when we throw our volleyballs, it's a negative a, because it's going to go up and we're going to find the height and the distance. So what they're wanting to do is find the height. Okay, so let's put in this equation. So it's -16x squared plus x. Okay, so it's going to be -16 x squared plus 48x, and it's going to be the last piece is plus 6. Okay. All right. So when they're launching these t-shirts, they are going. So let's look at this real quick. So they have a nice little parabola here. They are launching these t-shirts straight in the air. Okay. What's ironic to me is this talks about time in seconds. Okay. When we do ours, you guys will actually draw the actual, looks like the arch. Okay. This formula is a little high, but so graph the function. We did that. At what height was the t-shirt launched? Okay, so it's asking you at what height. What height would be, of course, let me go back to the home, it would be the value of x. Okay, so at what height did they launch the t-shirt? Well, it looks like somebody was about 6 feet tall, maybe, at 6, and they launched it at 6. So that gun, is this in feet? It's in feet. At what height was it launched? It was launched at 6 feet. Okay, how do we know that? Because of what I talked about. The Y-intercept here is 6. We will be doing the same thing. So the person is 6 foot tall, so they're about my height, and they're taking the gun and they're launching it right about right here at this angle. Okay, so that's 6 feet. They're shooting that baby up in the air. Okay, then it's asking, what is the maximum height of the t-shirt? Okay, and when was the maximum height reached? So the maximum height of the t-shirt was 42 feet after 1.5 seconds. Okay, so if your vertex is 1.5 and 42, this is the key I need to make sure you guys understand when we're doing this on a test. Okay, what is the maximum height? The height would have been 42 feet. If you tell me the maximum height would have been 1.5 feet, I would have laughed at you kind of, because I'm like, really? So what's the 42 represent? It's 42 seconds off the ground? No. And then how many seconds did it take? It took 42 feet and it took 1.5 seconds. Okay, so they launched it out in the air, and in 1.5 seconds it hit its maximum arch, and then it started coming back down. Does it give us a distance? Well, technically it does. That's why that's so ironic, is that apparently by the time 3 seconds passed, the t-shirt was on the ground. Does it tell us specifically like how far it went? No. Okay, it just says the maximum height was 42, and by 3 seconds the shirt was on the ground. So 1001, 1002, 1003. Okay, that's pretty cool. All right, that is a real world example of how you would do that. Okay, and that's what it means. Ladies and gentlemen, we have homework on ALEKS. Exit ticket in class. Okay, if you missed the second day of this class, which would have been Tuesday, the 5th of February, we did have an exit ticket. If you didn't do it in class, please come pick one up, because I want to make sure you guys get that done. You can turn it in any time. The exit ticket is actually related to the book. So if you don't have a book at home, you're going to have to do the exit ticket in class. If there are any questions about this, remember, we're looking at graphs and how do you interpret them. That's what today's lesson is about. If you have any questions, please come see me. Otherwise, good luck, and I'll see you soon in class.